Hello, class and professor. My name is Roman Luco, and this week's module, I will do a flight presentation called Running Rough. So, this will not be a verbatim slide by slide presentation, but I do need to present the scenario. During a recent trip, you had an engine that began to run rough, and you decided that you need to review one engine operative procedures and operations. Your local flight club is conducting a training session on the subject at its next meeting. So, in preparation of this meeting, I'm going to have to look into a couple things regarding my particular aircraft, the single engine procedures, and I'm going to refresh myself on certain V speeds that are important for multi engine aircraft. So, the aircraft that I'm going to be flying is going to be a Diamond DA-40. It's a single pilot aircraft. It is a light twin, which means it weighs less than 6,000 pounds. It has a FATIC engine, which is a full authority digital engine control. And we'll talk a little bit more about that later. And it has a full feathering propeller. So basically, what that means is I have complete control of the feathering, or rather, I should say, the FATIC system has complete control of the feathering of the propellers, which is going to be important when we talk about that inoperative engine situation. So, first thing we need to understand is the V speed, which is probably going to be the most important, which is going to be VMCA, which is going to be minimum controllable airspeed. Now, let's talk about what that provides. What that provides for us is simply directional control. So, in the event of an engine failure, we have lateral control of the aircraft. Now, we're not talking about climb capabilities at all, because, like I said, once you lose that engine, your performance is going to reduce a lot. So that's what it does not provide, the ability to climb. That just makes sure that if there's an obstacle in front of you, that you can move left or right out of the way of the object. And also, it provides you the ability to bank. And banking is actually an important thing that comes into play in terms of controlling the aircraft once you do lose an engine. So, how's it determined? So, each aircraft has specifics as to determining its VMC, but there are standard things that we use to determine it. It's an acronym called SMACFA, which goes into a couple different things. S is going to be standard day at sea level, because, like I said, that's a standard performance in terms of setting it. Max power, which is you're going to assume that you're going to be at max power in that situation. Um, excuse me. AFCG, a situation where you have less control because the center of gravity is back, so that rudder doesn't have as much control. Um, Critical engine windmilling, which is going to cause more drag in that situation. Um, Flaps up, gears up, which is another situation where you're going to have less control of the aircraft, because if the flaps were set, it would make the aircraft more stable. If the gears were down, the gear would act as a keel, giving the aircraft more directional control. Up to 5 degrees of bank, and this is another thing, just like the standard temperature and sea level. Just to give you a standard, because 5 degrees of bank is going to give you more control. But like if the manufacturer would say, okay, we're going to do 20 degrees of bank, that's extreme. And then you're going to have to talk about lift differential and stalling. And then most unfavorable weight. Most unfavorable weight for this aircraft is probably going to be the lightest weight, but for standard, we're going to use max weight. And that's how they determine what the VMC is going to be for the aircraft. So for the DA-40, the VMC is going to be 68 knots. And once again, you have to consider that's what an aircraft that's brand new. The aircraft I'm training in is a 2004. So the VMC is going to be a little different, but I'm in a high altitude area, so that does affect the VMC as well. So next important airspeed is VYSE, which is single engine climb speed. So for single engine climb, you have to remember this. When you lose an engine, you're going to lose 80% of your climb capabilities. So even though you've lost 50% of your power, you're going to lose 80, maybe up to 90% of your performance. So your expectations with that should be very limited. You should think about, hey, in this situation, I just want to climb to a safe altitude in order to make a decision on what I need to do. So everything's going to be situation based. And so, like I said, your expectations need to be hedged. For me, in most cases, I would assume, hey, single engine climb speed. First thing I want to do is figure out what's going on and make a decision from there. So once again, in the DA42, the single engine climb speed, which we call blue line, is going to be 82 knots. And so also with that aircraft, it has great performance. So even above 82 knots, it's still going to have a lot of climb. But in terms of flying another aircraft, it may not be the same. So single engine operations. So let's talk about what the procedure is going to be. So if we're on the runway, this is what you need to do. Um, if you lose an engine, first thing you want to do, pull the power. Pull the power, and you want to maintain directional control and apply brakes. And that's because the most important thing when you lose an engine is directional control. So you're not in the air, you don't have to worry about single engine climb speed. But if you have that throttle full forward and you lose directional control, you can end up going off of the runway onto the taxiway or another runway, and you could cause a runway incursion. So you want to be quick on pulling those throttles to idle and getting that aircraft stopped in order to figure out what's going on. Now, after takeoff, there's a couple different takeoff scenarios, but we're talking about after takeoff, gears up, flaps up. So it's funny, you actually want to do the opposite in this situation. Instead of pulling the power back, you want to go full power on both levers. After you go full power, you want to pitch down to blue line, which is 80, which is 82, to try to give you single engine climb speed. And then another thing you need to do, gears up, flaps up. But you want to get to that single engine climb speed as soon as possible, because VMC is just going to just only give you directional control. It's not going to keep you up in the air. So once again, you want to get to that 82 so you can climb enough to try to figure out what you need to do after that. And that's actually the next thing we're going to go into. So you either fix or you feather. Now, feathering, in most cases, I would probably feather. But it's a thing that you need to be aware of how to do and then to make a decision. So if you're going to feather, like I said, once you go through that emergency procedure of gears up, flaps up, getting the blue line, you basically need to cut off that engine or feather that engine. So with the DA42, all you simply need to do is do the identify, which is going to be dead foot, dead engine, verify, pull the throttle back on that engine, and then feather. And feather is simply cutting the engine off. Now, since it's a FATEC engine, it's going, once you pull it back, it's going to feather to the coarsest pitch, which is going to give you the least amount of drag in that situation. Now, you can fix it. Now, in terms of fixing it, even when you feather it, you may want to troubleshoot it, but your first reaction should be to feather because we're not sure how much time we're going to have to fix it. So in that situation, in terms of troubleshooting, you want to verify that A, the engine is on, the throttle is on. You want to make sure you have fuel flowing to the engine. So you're going to check your fuel supply. Then the next thing you want to do is spark. So spark, you're going to ensure that the ECU, because it's a FATEC engine, is on, that the engine master is on. And then you're going to verify that the circuit breakers are all in and operating. So at that point, once you see, hey, everything's working, there's no reason that this engine should not be functioning, then you're going to try a restart. And in this case, the restart is going to be very simple. You want to ensure that you have fuel flow. So that fuel that you cut off, you're going to cut it back on. Then the next thing you're going to do is make sure that the engine is idle, because the last thing you want is the engine to start the propeller to start windmilling once you cut on that power. So throttle to idle, that's very important. Then after that, you're going to cut the engine master on, and immediately you want to crank that engine. You crank that engine, you get up to 500 RPMs, and then once the propeller starts going, you want to check them engine instruments to see if there's going to be a consistent issue or so that you can determine if, hey, I need to land as soon as possible, or do I need to land as soon as practicable. So once again, if you have an aircraft with a rough running engine, you obviously want to be prepared for that. But in any situation, when you're flying a light twin, you want to make sure that you're well aware of the procedure so that your reaction time is fast enough so that you can save your life and your passengers and continue to have a great flight. So, my references are going to be the Aviation Instrument Handbook, the Diamond Aircraft AFM, and then the Airplane Flying Handbook. So once again, thank you for listening to my presentation, and always be prepared for single engine operations. Have a great day.